Okay, please don't forget to turn your microphone off so that we don't have any sound from the background. So today we are going to discuss a pretty interesting topic, data warehousing and BI. And BI is for business intelligence, not for business informatics. And what is special about this topic? So we have a chapter. The content of our discussion for today is pretty straightforward. As usually, we follow the Dama-Dierenburg structure. So the idea, first we can discuss some general stuff, something like a basic foundation of data warehousing. Then we can discuss what are major activities of this specific knowledge area, what kind of tools and techniques we can use to implement activities, to support activities in this knowledge area. Some guidelines is usually, but we can skip it at the end. But focus is on data warehouse and as a special sub-function in data management. And this is really very important function or group of functions. And at the end, you see we have some new homework. And this homework is aligned with the project pipeline. We will see it. So idea of this homework 5 is built in what we call multi-dimensional data model or dimensional data model for your particular database. Okay, so as usually, we have our framework. We have a Dama wheel. We have a context diagram with all details of this knowledge area. And we have some hexagon for environmental factors, describing golden principles, people, technology, and process, and all other stuff. But usually we focus on a context diagram to discuss activities, inputs, outputs, people involved. And of course, we look at Dama wheel to understand where exactly we have this particular piece of functions. Okay, so this is our piece of cake, data warehousing and business intelligence, which is, you see on a diagram, it's close to reference and master data and close to metadata. And actually, it's for a reason. It's not just occasionally. Because you remember when we discussed data integration and data interoperability, we mentioned that this DII knowledge area heavily depends on all these functions in the upper part of this Dama wheel. Architecture, modeling, storage, security. But it is critical. Data integration and interoperability is critical to reference and master data management and data warehousing and BI. So these two important sub-functions, which are close to what we call, okay, we have it here at the end of any project. So remember also this icons pyramid that we use to build something like a project, a data management project for our particular, I don't know, business case. And according to icons pyramid, we are in phase 3 now. And in phase 3, what we have master data management and we have data warehousing and business intelligence. So now we are here. After building master data management practice, we move to data warehousing and business intelligence. So we are going closer and closer to end users. So end users, those guys who are consumers of the business analytics results. something like this. So today we are focusing on this knowledge area. Okay, and again, so this is our project pipeline, and we are at the end of this pipeline. After master data, we go into data warehousing and BI, and this is piece of cake for this particular stage in your project. And we will have a special homework for this stage. Okay, so as usually, we can start with the definition. So generally speaking, concept of data warehouse is not new. So it exists for some 40 years. So from 1980s. And maybe some of you may say, okay, it's obsolete. Today, everybody is talking about data lakes, data lake houses, data fabric, etc., etc. But still, data warehouse for us and data warehouse for many companies, it's a really important data asset. So the concept, as I said, emerged in 80s. And it was a result or response to the need of companies, organizations. They need in data integration. So remember, data integration interoperability is critical for data warehousing. And data warehousing is a result or response to these needs of organizations to integrate data from different applications, from different sources, from different departments, I would say. And in modern organization, we have a wide range of sources of data, and we want to integrate them into common data model and common data component or infrastructure. And integrated data, they promised to provide some better insight into operational processes of the organization, and they open up some new possibilities for using data in support of decision making. So this is the idea. And also, as we expect, with the data warehousing, we can maybe get some additional value from data. And this is important because for us in economy of data, we are now in economy of data. Data is a valuable digital asset, and this digital asset should bring us additional value. This is the idea. And important also that data warehouses were considered as a special mean, okay, if we go here. Now we know that data warehouse is something like an important element of any digital infrastructure in any company, and especially data warehouse, not just a data warehouse, but as a combination with business intelligence capabilities. And this is what we use to support decision making. And this is a core of enterprise data management. This is also important. And what is also interesting about data warehousing, of course, this is a technology. We consider it not just something like an organization of data into special form, into special data base or whatever. No, it is a technology as a data integration technology, and it is considered also as a mean to reduce the use of decision support systems. Because you know, in previous years, maybe some 10, 15 years, maybe 20 years ago, the decision support systems as a special kind of applications were very popular in organizations, and they were considered like a special expert systems in support of decision-making process at different levels in organization. And we had a lot of off-the-shelf software packages, some software applications called decision support systems, and many organizations invested into or purchasing and installing and using these systems. But what is interesting and important about data warehousing and data warehouses in combination with BI, with this strong combination between data warehouse and BI, we can forget about decision support systems, because data warehouses in these days, they in many cases substitute functionality of the complex decision support systems. We don't need it. So most of functionality like business analytics or data analytics, the complex machine learning and other algorithms, they are now integrated into data warehouses, data lake houses. So we don't need special applications like DSS. So this is, as you can see, data warehouses in many organizations consider as a means to reduce the proliferation of decision support systems. And also important, we consider data warehouses in many cases like a special technique to reduce data redundancy as a special technologies that can improve consistency of information and enable enterprise to use data to make better decisions. So this is important. And we have a lot of publications about it, about data warehousing. At the end of this presentation, we have, I don't remember, something like 2-3 slides with links to different blogs, to different videos and different papers about data warehousing, and I just recommend you to look at it. In our presentation, we are focusing more on Dharma Dierenbock, and we use information from this textbook. But in addition, I can recommend you some maybe most recent publications. Okay, so one of these publications from 2022, you see this is a blog from Shoaib Nemri, pretty interesting guy. He's something like a machine learning architect from Amazon Web Services, from AWS, and also from Google. He's a pretty well-known expert in this area. So a pretty nice discussion in his this blog about data warehousing, data lakes, data lake houses, data meshes, what's the best architecture for your business. Just you can go there and check it. But just a couple phrases, couple paragraphs from his discussion on data warehousing. So according to Shoaib, data warehouse is large repository of structured data assets in your organization. And other terms used to describe this concept, something like a synonymous to data warehouse that we can find in other literature. Enterprise data warehouse, and this is a pretty popular term, EDW. Then decision support systems, they can also be considered like data warehouses these days. And data mart, this is also a pretty popular term these days. And in some literature, data marts are considered like a data warehouse for your particular needs. And later on, we can discuss it in more details. What is a data mart and what is the relation between data mart and data warehouse? Is it the same or is it a difference? And so as you can see, these terms in literature are used interchangeably. And sometimes even within the same organization, people from different departments, they use these terms interchangeably. So, but anyway, the most important characteristic of this data warehouse, according to Shoaib, is that it is a centralized data store mechanism in your information system. So it means that with the data warehouse and with the data warehousing as a process, we integrate, we collect, and we store data, all of your enterprise data, in one location. So this is idea here. What else? So this is illustration from this paper. And it explains exactly what are the major components of data warehousing as a technology, as a process or technique. So as I said, again, data warehouse is a large repository of structured data assets. So this is a central data store in your organization, all data in one location. How we can collect all data in one location? First of all, we have variety of data sources. It's at the bottom here. It can be some external data or internal data like operational data. It can be transactional data or live data coming from different business transactions. But important is that all of this data go through the process of ETL, extract, transform, load. And this is a special kind of applications and transformations that integrate all these different data into a format that is appropriate for data warehousing. So idea is data from different sources, internal, external, go through the ETL process, and then they form a data warehouse. And what is the purpose of this data integration and data preparation into specific format? The idea is that data in data warehouse are used for specific purposes. They can be used for digital reporting, microphone, digital reporting, for special kind of analytics, and business intelligence or business analytics. So this is important according to NEMRI's definition of data warehouse. So data warehouse is not just integration of different data in in one location, but this data is transformed in such a way that this data can be easily used for specific purposes, reporting, analytics, and BI. So this is idea. And what else here? Again, just to summarize, last slide from this paper. So data in data warehouse will be used for reporting, analytics, and business intelligence purposes. We're talking about variety of data sources. It can be transactional data, operational data, data from third-party sources, historical data, or real-time data. Then we're talking about a range of data sources. It can be industrial data from sensors in your, I don't know, manufacturing equipment. It can be relational databases in your different kind of applications. Remember, we discussed that we may have hundreds of software applications in your organization in different departments, and each of these include, in many cases, some databases. Okay, so these relational databases, they represent some sources. Hadoop and NoSQL databases can also be source of data. Mainframe computers, in some companies we have it something like a local data center with a mainframe. Enterprise research planning, ERP systems, CRM systems, HR software application, etc. Then data archiving systems, data catalogs, and many more. So all these different kind of sources can be integrated in a data warehouse. Important is that they should be formatted, cleansed, and prepared for the specific format that is appropriate for the data warehouse. So this is idea. Okay, now as usually, if you go to the context diagram of this particular knowledge area, what we have, usually we look at business drivers. So what could be the major business drivers for organization to establish data warehouse, and BI functionality? It's pretty straightforward. Now, the first and major reason is support of the BI and support of the decision making. So this is the primary driver. And increasingly, organizations, they also want to find solution to support compliance with the external regulations. Also, data warehouse and BI can be helpful in this because data warehouse contain and databases in any organization contain a lot of historical data. Data warehouses, they can also be used to support these regulatory requirements for those data, historical data. And business intelligence support continues to be a primary reason for the data warehouse. So BI support for us is something like #1, and decision support #1 business driver for establishing data warehouse functionality. And organization that acts on knowledge, Ali, microphone, Ali. Okay. So as more data become available at a greater velocity, business intelligence, now it is a really important functionality to provide decision support, some predictive analytics, and all this analytics is based on data warehouse. Okay, thank you, Ali. So what else? Some words about goals and principles. As usually, we also have the goal of data warehousing in any organization is, first of all, to build and maintain a technical environment. Data warehousing is technology. So we need to build and maintain this technical environment and technical and business processes associated with this environment needed to deliver integrated data in support of operational functions, compliance requirements, and business intelligence activities for decision support. So idea is to support business analysis and decision making. So this is important. And usually data warehouse at any organization is established to support in order to make three important things. First, to support business intelligence activity, to enable effective analysis decision making, and also find the ways to innovate, find the ways to digitally transform your business based on insights from data. Because business analysis, BI, provides us those insights. It extracts some knowledge, some information, important information about your business that you can use to improve your business, to innovate, to transform your business. So these are three major reasons for any organization to establish data warehouse in your information system infrastructure. And guiding principles to do it are something like this. Usually we start with a business strategy, business ideas, business problems in your organization, and focus on any digital infrastructure development activities is with the business goals in focus. And all other stuff, no need to discuss it in more details, but there are some interesting things here. The guiding principle: build metadata with the warehouse. What does it mean? It's a pretty interesting guiding principle. So if you build your data warehouse, don't forget about metadata. And this is really critical to any data warehouse success, is ability to explain data inside data warehouse. How we can explain data? We can use a metadata. Metadata explains other data. So it means that guiding principle, building metadata with a warehouse, means that metadata should be captured as part of the development cycle, and metadata should be managed as part of the ongoing operations on data warehouse. And okay, if we quickly go back to demo wheel, you will see that data warehouse on this diagram is close to metadata. So perhaps if time permits, we will have some special lecture, some special class on metadata to discuss how important metadata is in any data infrastructure. But specifically here in our discussion, it is important to mention that data warehousing is really closely related to two functions in data management: metadata management and data security management. So you remember here we have this CRUD metrics, and CRUD metrics describe relations between different roles and different data elements. So essentially here we're talking about communication or interactions between different actors in your organization with respect to data. So we have different departments, we have different applications that write and read data from different elements. And it is important for data warehousing, because in data warehousing, we are building a single source of data for all departments, for all consumers, for all users. And this is really important to do it in the right way, taking into account these CRUD metrics. And also important for data warehousing is metadata, because metadata should explain what we have inside data warehouse. How we can do it? We can do it through metadata. Okay, so this is an important guiding principle for building data warehouse. There are some other important stuff like collaboration, because we are building enterprise-wide infrastructure, data warehouse for all departments, for all enterprise. So we need to collaborate in building such a universal infrastructure. Okay, and now we can go to some important, something like a theoretical stuff. It's not actually a theory. There is no any mathematics or complex theory behind the data warehousing, but there are some kind of foundation that we need to know, that we need to understand before we can go to some practical stuff. And first of all, the term BI, So we're talking about data warehouse and we're talking about BI. BI, it's a pretty interesting term, actually, because, you know, in our program, we're talking about business analytics and big data systems. So business analytics can be enough for us. But in the literature, it's a pretty popular topic is BI. For me, it's the same. BI, it's about business analytics. But business intelligence in literature, usually we consider it like two important things. First of all, we talking about very special type of data analysis. So data analysis, which is focused or which is aimed at understanding business processes, organizational activities, and business opportunities. So idea of this data analysis is very special. Focus on business, focus on your enterprise, focus on your processes. So this is why we call it not just business analytics, we call it business intelligence. And result of such analysis can be used to improve business processes, organizational success, and maybe transformation or innovation of the business, etc. And what else? And secondly, as you can see, we also use BI to describe a set of technologies in support of data analysis focused on business processes. And evolution of decision support tools, decision support systems, and we can consider BI tools as evolution of this decision support system or substitution of the decision support systems. BI tools enable different functionality. So we have functionality for data querying, for data mining, or statistical analysis can be embedded into BI tools. Pretty complex mathematics, probability, mathematical statistics, and some other stuff. Digital reporting can be part of the BI tools. Scenario modeling is a business scenario or organizational scenario. Data visualization is also part of the BI. And in most of cases, for most of people, for majority of people, business intelligence is just a nice dashboard, visualization. But actually, data visualization is just a part of BI functionality. More important is this kind of mathematics, data mining based on machine learning and maybe artificial neural networks and some soft computing, fuzzy logic, or other complex algorithms. Or mathematical statistics and probability theory can be also implemented here. And visualization is, as usually, at the end of the data pipeline. So after all of these transformations and complex computations, we can get nice diagrams. So dashboarding, data visualization is at the end of long pipeline of data transformations. But anyway, as I said, BI, we can consider it like set of those technologies in support of data pipeline. And they are used also for everything from budgeting to advanced analytics. And this is important. So BI these days, it's not just diagrams that you can bring to the CIO or to the top manager in support of his strategic decisions. No. BI these days can be used at different level of management in your organization, from operational management and up to, I don't know, strategic management. So this is important. So this is about BI. It's a special data analysis focused on business and organizational activities, and this is a set of technologies in support of data pipeline. Okay, and now about data warehouse. And we have two components in any data warehouse. First of all, it is a database, integrated decision support database. So it's not just a database as collection of some facts, some measurements, some raw data. You remember that before we can load data into data warehouse, it goes through the ETL process, extract, transform, and load. So we transform data, raw data, into specifically formatted data prepared for data warehouse. And this database, we call it decision support database. And second component, in addition to this database, we have a collection of software programs or applications that we can use to collect data in this database, to cleanse data, transform data, store data from a variety of sources. And this is important also. Data warehouse may include collection of data marts, dependent data marts. And what are those data marts? Data marts are considered as a subset copies of data from the warehouse. So now, remember I mentioned that we need to understand the difference between data marts and data warehouse, because in some organizations, in some cases, people use these two terms interchangeably. But you know, in case when data warehouse is just a single data mart, we can consider, okay, data marts is a data warehouse. But in most of cases, we have a single data warehouse, and we may have number of data marts. And each data mart, it's a different subset of data from data warehouse. So this is idea. In more exactly, just imagine we have a data warehouse as a central data repository for some organization, and we have some 10 different departments in your organization. And each department requires a specific decision support and specific analytics. And we may have, I don't know, 10 data marts built as a subset of data from the data warehouse, and each data mart serves a specific data analytics needs of a specific department. So HR department has a specific HR data mart. I don't know, marketing department has their own data mart, etc., etc. So this is the idea here. We have a single data warehouse, and we may have number of data marts for specific customers of these business analytics, of these BI solutions. So in its broadest context, data warehouse includes any data stores or any data extracts used to support delivery of data for BI purposes. So this is a general idea. And also we have a special term like enterprise data warehouse. So this is a centralized data warehouse designed to service BI needs of the entire organization and all departments. And what is important in this enterprise data warehouse, so we have an enterprise data model. And when we build such a enterprise-wide data warehouse, first we need to have a pretty good enterprise data model to ensure consistency of decision support activities across the enterprise. So this is idea behind enterprise data warehouse. Because you can build actually data warehouse for each department. So instead of using data marts, you can have your own data warehouse. But it is really makes sense to have something like a centralized data warehouse with an enterprise data model, and all other decision support activities should follow the same standard, enterprise-wide standard. Okay, what else about data warehousing? So traditionally, data warehouse focuses on structured data. So this is important to mention here. And what is a structured data? All this relational database is a structured database. So we have elements in some well-defined fields in a table, and it can be table or files. But what is important about structured data, that elements well documented, we know exactly location of different elements. And originally, data warehousing was focused on those structured data. But now, these days, as you can see at the end, BI solutions, modern BI applications, and modern data warehouse embraces semi-structured and unstructured data. Because majority of data these days, it's really unstructured data. It can be emails, it can be free format text, business documents, videos, photos, web pages, and you can mention a lot more examples of unstructured data that circulate in business environment. And we need to deal with this kind of data as well. And modern data warehouses, they are designed to collect, to structure, to format, to organize semi-structured and unstructured data as well. And this is important. Okay, now some words about approaches, how to build a data warehouse. First, we can look at some historical stuff, how this data warehouses started actually. So, and here we have these guys like pioneers or the major experts in data warehouse. So they are really leaders in data warehouse research and development area. And to these guys, Bill Inman and Rolf Kimball, they advocate two different approaches to building data warehouses. They are different, but they share some stuff. We can discuss it now. So first of all, if we look at Inman's definition of data warehouse, so according to Bill Inman, data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. So this is important in his definition. And also important, especially important, is here. I did not highlight it here, but normalized relational model is used to store and manage data in data warehouse. So according to Bill Inman's, data warehouse is built on normalized relational model. This is a big difference from Rolf Kimball. So Kimball defines data warehouse as just a copy of transaction data, specifically structured, for query and analysis. So here this focus on transaction data, and this data should be somehow transformed into specifically structured form, which is good for query and data analysis. So this is the idea. And what is important about Kimball's approach is that according to his vision of data warehouse is based on dimensional model, not normalized relational model, but dimensional model. In some cases, we call it multi-dimensional model because usually we're talking not just a single dimension, but we're talking about several dimensions in our model. But this is a big difference between these two approaches. And we have illustration in a textbook. To the left, we have something like a architecture of the data warehouse according to Bill Inman. So Bill Inman introduces what he calls a corporate information factory. So CIF structure, where data warehouse in the middle of this factory. So what we have here, we have some sources of data, some operational systems that generate for those data. But then we have ETL process to transform the raw data into format which is good for enterprise data warehouse. And enterprise data warehouse, as you can see here at the bottom, integrated repository of atomic data in normalized relational data format. And then this enterprise data warehouse can be used by different applications like decision support systems, for example, or some application for data mining, for data exploration. And it can be used to generate some data marts. And you remember data marts, they are user specific. So these are users from, for example, different departments. Marketing, HR, I don't know, some other ERP guys. And for all of those guys, we may have different data marts that can be used to create some BI solutions, some visualizations, some reporting, digital reports, or whatever, to those particular users. So data organized for departmental analysis in dimensional format. So what is important here, enterprise data warehouse is in relational format, normalized format, but data marts, which are, you remember, subsets of data in data warehouse, they are organized in dimensional format, which is better suited for BI applications, BI solutions. And if we're looking at Rolf Kimball, what we have also some operational applications, sources of data. We have, again, ETL process, but at the end of this ETL process, we have dimensional data warehouse. So we don't need to use any relational database here, like it is in Bill Inman's architecture. We directly go to dimensional data warehouse, which is to the right. You can see this is something like a cloud. So this is a combination of data marts. So all of these elements, these are data marts. Subject area within the data warehouse. And end users can get what they want directly from the data warehouse using specific BI applications, BI solutions. So this is a difference between these two. And but anyway, you can understand difference from this diagram, but also you can mention that there are some important things in common, which are in common in two architectures. Because both of these are based on the similar core ideas. First of all, warehouses, they store data from other systems, internal systems in your organization or external systems outside your organization. But idea is that warehouse integrates data from various sources. The second, the act of data storage includes organizing the data in a special way that increase its value. So ETL process. First, we transform raw data into format which is good for data warehousing and which is good for BI, for further analysis. So this is important. The third idea is that data warehouses make data accessible and usable for analysis. You remember data warehouses, the focus of data warehousing is to make data available for different kind of analytical applications. So this is idea. Then organizations build warehouses because they need to make reliable, integrated data available to authorized stakeholders. Authorized stakeholders, so the people from different departments who are really authorized to use this data for their particular needs, analytical needs. This is important. And finally, warehouse data serves many purposes. And it can be simple support of workflow, something like automation of some operations, business processes in your organization. It can be operational management. It means that management at low level, at level of specific operations in your organization. And it can be anything up to predictive analytics that we use at level of strategic management. So as I mentioned before, warehouse can serve many purposes, analytical purposes at different level in hierarchy of management in your organization, from level of operation on a shop floor up to level of CIO and other C-level people in your organization. So this is important here. Now, in some more details, we can look at these two architectures. First, we can start with the corporate information factory architecture from Bill Inman. Why it is important? You know, some people, I remember last year, one of the students, he just wrote a comment in a chat that, okay, these days nobody uses Bill Inman's architecture. So Rolf Kimball's is the major architecture for data warehouses. Just we don't need it. No, it's not exactly like this. There are some advantages of the Bill Inman's approach because you can really, in many cases, in many companies, we have something like a legacy databases, relational databases. And the easiest way to integrate those databases is to use a normalized relational scheme or model to create something like a single source of truth, centralized data infrastructure. And then from this relational data warehouse, you can generate any number of dimensional models for specific analytical needs, depending on what kind of BI application you have. If you have Power BI, okay, you can just create some what we call star schema for this software. Or if you have some other BI application, I don't know, Tableau or whatever, so you can build this dimensional model data mart for specific BI solution. So I think it's still it is really helpful architecture, and specifically in your project and in your homework, it is really what we need to do. You take your relational database from your particular business case, and you can build a data mart, 1 or 2 or 3, for specific BI needs, for specific analytical needs. So this is the idea. So let us take a look at this corporate information factory with the enterprise data warehouse as a normalized relational database. So what is important here? So if we consider enterprise data warehouse as a single source of truth, single source of data in your organization, important is that according to Bill Inman's architecture, it is not intended to be queried directly by analytical application. So first, we need to build a data mart, and then we can use this data mart in specific BI tool. So this is idea behind this architecture, Inman's architecture. So, and usually enterprise data warehouse in this case is stored in a relational database management system. And we use third normal form database design. So essentially, this is what you have done in one of your homeworks, something like this. So we may consider it like you already have your data warehouse or something like some foundation for your data warehouse as a result of one of your homeworks. And in this particular case, what we have data marts, they're here on a diagram, data marts. They are essentially some databases or excerpts from the enterprise data warehouse, some subsets of this enterprise data warehouse that support departmental view of information. So each data mart here is a subset of data which are important, which are needed for specific department, for specific analysis of a specific department. And this is a pretty good solution, actually. And in many cases, it works perfectly in many organizations, especially it's not a huge organization, maybe some small or medium-sized enterprise. It's just a workable solution, easy implement and pretty well organized. So in terms of architecture, it's a pretty good architecture. And data marts, they may aggregate data from atomic representation in the enterprise data warehouse. And each data mart takes info from the data warehouse and readies it, transforms it into form which is good for analysis. So you see, we also use dimensional design for data marts, the same like with the Kimball's architecture. So dimensional design is a perfect organization of data for any BI solution, for BI tools. So this is the idea. We take relational database, we take some subset of information from this database, we create dimensional data mart, and we use it like an input to BI tool. So this is idea here. Okay, so what are major components of this architecture, build architecture? We have applications, we have staging area, and applications are here, you see, to the left, all these, I don't know, CRM, ERP, etc., application that we may have in your organization. All of them generate some data, and data from operational processes, as we call it, operational reports per application. And then those data go to the staging area. Staging area on this diagram is represented by this block, integration and transformation, and partly data warehouse also can be considered like part of this staging area. And so this is essentially where ETL process takes place. Extract data from here, transform data, and then load data to data warehouse or to operational data store here. And then integration and transformation, this is element of the architecture where data is transformed to be integrated into standard model in data warehouse or in operational data store. So essentially here we format data, we clean data, we transform data and format data to be included into data warehouse. Then important component here is ODS, operational data store. So essentially this is also database, similar to data warehouse, also something like a relational database. But important is that here we have what we call operational data. It means that data, something like short-living data, I would say. So operational data that are collected from the real processes. And this data is important and used during, I don't know, some short time frame. So you see, as you can see, operational data store contains current or near-term data, 30, 90 days. So it's something like 1 month or a quarter. And this is different from the data warehouse where we have all data from your organization, from all activities. So it is about historical data, not only short-term data, but also long-living data, data for years, maybe months, etc. So historical data are important, and these data especially important for some strategic decision-making, for building some forecasting models, etc. And this is important. Then we have a data marts here, DMs, and they provide data for analysis, departmental data, departmental analysis, remember. And in between we have so-called operational data mart. And this is a pretty interesting infrastructure. So this is a data mart which is focused on tactical decision support. So if historical data in data warehouse is good for strategical decision support, as I said, something like forecasting what can happen in to our business in some 5 years, 10 years, based on history of business development over the last 3-5 years. In operational data mart, especially if we're talking about operational data taken from ODS, we can make predictions, or we can support what we call tactical decision. Tactical decision support, so something like what we need to do next month, what we need to do next quarter, or within a period of time of just few weeks or few months. And our data warehouse in this case is something like a single integration point for all corporate data to support decision making, strategic analysis, and strategic planning. So this is the idea. And also on this diagram, what we have some data flow, as you can see. So data flows into our data warehouse from application systems and from operational data store. And data from the data warehouse can be used by data marts for analytics, and all these applications to the right. Operational analysis, exploratory analysis, or just data analysis for a specific department, etc. So this is what we have on this diagram. So as I said, it's not just components of the architecture, it also shows some data movements within the data warehouse, data warehousing or data infrastructure based on in-month architecture. So from data collection, data creation via applications on the left, to the creation of information via data marts and analysis. And movements from the left to right includes also not just changes in data. So from raw data to formatted data and to data ready to be present in some diagram types, but also some other changes in shifts in business can also be considered here. So from execution of some operational functions like here to analysis. And end users of those systems, they move from just line workers that use all these applications here to decision makers who use results of this analysis to the right, etc. Important is on this diagram that data in data warehouse, they differ from data in applications. Data in data warehouse is organized by subject, but not by function. So in application, data is arranged by functions, functionality of those applications. In data warehouse, more important is subject. And data is integrated here, not just collected from many, many sources. They are really integrated, formatted and integrated with a purpose. And purpose is analytics. This is important. Data is time variant versus current valued only. So you remember here we have historical data, here we have operational data. And this is also important. And data in data warehouse has higher latency than in applications. And it is really, there is a reason for it, because it is a single storage for all enterprise-wide data. So usually getting access to this data, it takes time. And it's a lot of historical data here and also operational data and different kind of additional data. Remember also metadata. In data warehouse, we also need to have a component that describes what we have inside. So usually it's getting access and processing data in data warehouse has a higher latency than in those applications because they are closer to data, sources of data, and they generate data themselves. This is important. Okay, so this is about architecture by Bill Inmons. It's a pretty straightforward. You can easily understand all the peculiarities of this architecture. And building data marts from relational data warehouse, it's pretty straightforward. You can do it easily. Okay, and what is, just to summarize, what is important here, we just discussed the movement of data from left, from applications to the right to end consumers, and different kind of changes. And the data in data warehouse and data marts differ from that in application. This is for sure. Data here and data there are different. Okay, now some words about Ralph Kimball's dimensional data warehouse. As one of the students mentioned, that this is the most popular architecture actually these days for data warehouse, more popular than Bill Inmons. Well, maybe yes, maybe not, but anyway, what is special here? We don't have any normalized database. So directly from data sources, from all of these operational applications, we go through the ETL process, extract, transform, load, and we load dimensional data warehouse. So we don't have any intermediate relational database. So this is, maybe this is advantage, but anyway, this is our process, how it is here. And dimensional data warehouse is the end result of the ETL process. So this is a major difference. It is integrated repository for atomic data in your organization, single view of business activities, and it stores that information in highly granular or atomic format. Highly granular format means that we can use it directly from the data warehouse to different analytical purposes. Because data marts are here, they are inside data warehouse. So this gray box in this cloud represents just one data mart, subject area within the data warehouse. And you can get access to this data mart directly from your BI application. So this is one something like a advantage. And this gray box or in the cloud is what we usually call a star schema. Star schema means a dimensional model that comprises facts and dimensions. So facts here, so one of these small boxes in the middle, these are facts. It's a quantitative data about your business processes. Like, for example, I don't know, sales numbers. So important is it's a quantitative data, data that you can measure. And those facts, they are in the middle of this star schema and is surrounded by what we call dimensions. And dimensions in this star schema They are descriptive attributes related to the fact data in a fact table. And these dimensions allow consumers, those guys who want to use this data for some kind of analysis, they allow data consumers to answer specific questions about those facts. Facts, quantitative numbers about your business processes. For example, you may ask question, how many units of specific product were sold this quarter? So sales department want to make such an analysis, okay? They have their own BI application and they use data mart with the facts here to answer this question. What is also important in this implementation that our fact table in the center of star schema joins with many dimension tables. So you see, for example, here on this diagram, we have one fact table and we have something like 4 dimension tables. And it appears to be like a star diagram. So this is why we call it star schema. So star schema is equivalent to data mart. So in many literature, when we say, I want to build a star schema, it means that you are going to build a data mart for specific facts with specific dimensions that describe attributes. Okay, it's 19:30. We can make a break. Some, don't remember, 10-minute break. So please, you can just take a cup of coffee or whatever, and I will make a break as well. Okay. Stop sharing and pause it. 10-minute break. Okay, guys, let's get back to our session. We are here. So, any urgent questions in chat? No, no, no. Good. Okay, we are somewhere here. I believe, or I hope that you understand from this discussion what is the major difference between two architectural solutions for data warehouse from Bill Inman and Rolf Kimball. So essentially, the difference is in a model of the data warehouse as a central data store. So we have relational EDW or enterprise data warehouse, or we have dimensional data warehouse. And dimensional data warehouse, according to Kimball's model, is different in two important ways. First of all, it is designed from the very beginning according to the principles of dimensional modeling. So here we don't use any relational data model. Relational data model, remember what you did in your homeworks, it's ER modeling, entity relation. But dimensional modeling is different. So this is important here. And dimensional data warehouse, it's a series of star schemas or cubes, so which are here in a cloud on this diagram. So all of these star schemas, they are inside the data warehouse in this case. And star schema capture information about your business process, about entities, if you want, in your business process, all components at the lowest level of detail possible. In Inman approach, this is relational modeling, entity relation model. And then also important difference is that analytical applications like BI applications, they have direct access to those star schemas, to those data maps or cubes. So you see, in dimensional data warehouse, we can provide this direct access to analytical systems. And data marts is a subject area within the data warehouse. So this box, gray box diagram here shows just a single star schema or single data mart. And again, about star schema is combination of two important components. So we have facts and we have a special fact table. Facts, these are quantitative data about business processes. And we have dimensions, dimension tables. Dimension tables represent attributes that describe those facts. And these dimensions allow data consumers to answer specific questions about those facts. So if you want to analyze sales, okay, we have numbers about those sales and we have dimensions that can help us to better understand those numbers. And BI application can use it to visualize or to generate some kind of reports. So this is important. Also important in this organization, and this is something new comparing to Bill Inman's architecture. Multiple fact tables. So you imagine if you have several data marts or several star schemas, for each of these star schema, we have a fact table, and we may have multiple fact tables in data warehouse. And those can share the common conformed dimensions. So dimension tables used in star schemas can be shared by multiple fact tables. And to share those fact tables in Kimball's data warehouse, we have a special structure, a special component called a bus. Something similar to a bus in a computer. So we have number of components on printed circuit boards, and we have a bus to connect all those components, processors, and some memory chips into system. So similar is here. So all data marts are star schemas in Kimball's data warehouse. They are connected by a bus of something like conformed dimensions, common conformed dimensions. And multiple data marts can be integrated at enterprise level by plugging into the bus of conformed dimensions. And on a diagram, we can see it like this. So you see here we have this blue arrow, and this is data warehouse bus, conformed dimensions, and number of data marts using this bus as a shared dimensions. Okay, some more about this bus. It is a matrix, the data warehouse bus in Kimball's implementation can be represented by this kind of matrix. And it shows intersection of business processes to the left that generate fact data, some measured quantitative data, and data subject areas. And these subject areas represent dimensions in this case. And opportunities for conformed dimensions exist where multiple processes use the same data. So on this particular example represented on this slide, you see that we have something like a sample easy bus for the data warehouse, Kimball's data warehouse. So we have something like 3 major business processes like sales, inventory, orders, and we have data required by those business processes. So data and product. So what is special here? Sales and inventory, 2 processes. Both these processes require the same dimensions. They require store data and inventory and orders processes. They require vendor data. You see here. And date, product, and vendor, they all are candidates for what we call conformed dimensions. Dimensions needed to all or most of processes in your particular business case. And but at the same time, if you look at warehouse data, it's not data warehouse, by the way. In any company, we can have a warehouse where we can store products, where we can store different kinds of materials, etc. So in terms of business, specific business, warehouse and data about this warehouse is only needed to inventory process. Other processes, they don't need any information from the warehouse in this particular example. And this is why warehouse data is not a conformed dimensions. So you see conformed dimensions here: data, product, store, and vendor data. conform dimensions. And warehouse is not. Something like this. And enterprise data warehouse bus metrics can be used to represent what we call long-term data content requirements for the data warehouse and BI system. Independent on technology. So here we don't talk, we are not talking about any kind of, I don't know, applications or technology needed to implement it. It's just a metrics representing these conformed dimensions, describing the data warehouse bus, as we call it. And this tool, this metrics, enables organization to scope manageable development efforts. So using these metrics, we know how to develop what we need for implementing data warehouse, dimensional data warehouse. And each implementation builds an increment of the overall architecture. So we can implement data warehouse architecture step by step, and this is pretty good for the overall development. So we don't need to design data warehouse as a system from the very beginning. We can do it in several small projects incrementally, step by step. This is a diagram that shows architecture, so something like high-level representation of the data warehouse architecture according to Kimball. And now what is special here in this, the same like with the Bill-Inman's architecture, we also have some sources, data sources. We have some staging area where this data go through the ETL process. But there are some differences. Operational source systems here to the left. And these applications, they create data to be integrated into data warehouse or operational data store, as it was in Bill-Inman's architecture. And this component is essentially similar to what we have in SIF diagram. So you see here, we have operational source systems and we have applications to the left. So pretty similar. Okay, then data staging area. In Kimball's architecture, staging area includes something like processes, a set of processes needed to integrate and transform data for presentation. So it can be compared to a combination of integration transformation and data warehouse in Bill-Inman's architecture. Then we have a data representation stage or data presentation area. And this is essentially data warehouse as a combination of data marts united by data warehouse bus by conformed dimensions. And this is similar to what we have in Bill-Inman's, this combination of data marts. So here we have combination of data marts and here we have combination of data marts. But the difference is that there is not any connection between data marts in Bill-Inman's architecture, but here all those data marts are connected to each other through conformed dimensions. So this is a difference. So data warehouse bus, it's a special element of this architecture. And then we have data access tools. And in Kimball's architecture, the focus is on end user requirements. What are requirements of data users or consumers of the data analytics results? And these needs of these end users drive the adoption of appropriate data access tools. So what kind of data access tools here? So we can generate some ad hoc queries and use specific data access to specific data mart. If you're talking about some digital reporting, and users here are writers of those reports, and they use their own access to specific data mart to generate those reports. Analysts can use specific analytical applications and specific access to data mart that provide results of this analysis. And we can use different kind of models, data mining, machine learning, scoring models using machine learning, forecasting again. And those analysts who use those models can get access to specific data mart. So this is the idea behind the Kimball's approach. And these are major components. Also, we can look at data-aware architecture slightly differently, like this one. So data warehouse and big data architecture. A pretty interesting illustration in a textbook. It shows not only components of the architecture, but also shows how data moves from the source systems through the staging area, then to warehouse, and from warehouse to data marts, cubes, and to specific analytical applications, like BI applications. So from the data warehouse, it may be accessed via data marts and data cubes and used for different reporting applications. So something like this. And what is also interesting in this application, that it shows or presents something like a data lifecycle in your information system, in your enterprise-wide information system. So data moves from the source systems, from the source application, from different departments into a staging area. In a staging area, it can be cleansed, it can be enriched and formatted according to specific needs of the data analysis. And from the data warehouse, it goes to specific data marts. So this is. So what about source systems? Source systems, usually these are operational applications, software applications, and some external data, for example, data coming from some sensors or from different vendors who can give us some database access to specific data. And this external data and internal operational data can be integrated into data warehouse environment. So this is about source system. And data from vendors and external sources may also be included. For example, on this diagram, we have, you see DaaS, so data as a service. So from cloud provider, we can get some data as a service for our purposes. And modern companies, especially those companies who deal with these LLMs, with developing generative AI applications, they are really, they are starving and they are fighting for data. They need data to train their model. They need data to improve their quality of predictions, quality of results of those models. And data, where can we get those data? One of these source of data can be services from the cloud providers, data as a service. Why not? It can be. Web content can also be here used for these purposes, and many big data computations, big data results can also be as a sources for your data warehouse. And then data integration. This is essentially ETL process, classical ETL process. You may say that these days everybody is talking about ELT process. So we can extract data and load data immediately into data lake or data lakehouse. And then inside data lakehouse, you can do whatever you want to do. Because typically data lakes and data lakehouses, this is a combination of data storage and pretty complex data transformation capabilities. But anyway, for classical data warehouse, and today we are discussing something like a theoretical stuff, ETL process is used for data integration, data virtualization, and some other techniques can be used to get data into common form, into common format, into format which is good for data marts, to star schema, and for analytics. So this is important. And all errors on this diagram, where is this? It shows this integration process. Then data storage areas, another component of this diagram, this system. Here we have staging area. Staging area is here, you see. Staging area is something like intermediate data store between original data sources, applications, and external data sources, and the centralized data repository, data warehouse. And data is staged in this particular staging area just for a certain period of time, just for the period of transformation, integration, and preparation for loading to the warehouse. Then another storage area, reference and master data are conformed dimensions. So dimensional tables describing facts, you remember. And here we're talking about reference and master data. Remember, single source of truth, golden records. And here where we have MDM, master data management, and the reference master data, conformed dimensions, a special storage here. And this is important. So data warehouse feeds new master data and in turn is fed by conformed dimensions, content of this conformed dimension from the separate repositories. So this is how it works. Then we have a central warehouse here. You see, subject-oriented, non-volatile, time-variant, atomic, historical data. So this is important storage here. And several design elements can be mentioned here when we're talking about this central warehouse. Relationship between business key and surrogate key for performance. Creation of indices and foreign keys to support dimensions. We have a special change data capture technique to detect, maintain, and store history of data, and some other special techniques which are popular in implementing. Then we have data marts and cubes. And data marts is a type of data store, often used, where is it? So data marts, cubes, and operational data store. So these are major elements in data storage areas. And data marts is used to support presentation layer of the data warehouse environment. So presentation layer is using all this stuff. And what is new in this diagram comparing to, I don't know, Kimball's diagram? So you can integrate this diagram easily into this box. But we also have interesting pipeline at the bottom of the diagram with a big data label here. And this is pretty interesting because here we're talking about a different kind of load. Where is it? Different kind of load. And one load is historical data. In Bill Inman's data warehouse, you know, all data is stored in a single data warehouse layer. In a Kimball, we have combination of departmental data marts. So different data marts, they are specific to information, to data related to specific departments in your organization. So in Inman's data warehouse, we can build a data mart for specific department if needed from the single data warehouse. But in Kimball's, from the very beginning, we designed data warehouse as a combination of departmental data marts. So this is a big difference. So batch change data capture. It means that the load process in data warehouse can accommodate variety of change detection. So we have a special procedure to detect changes in your data. So one popular technique here is CDC, change data capture, CDC. I can keep it. We can skip it because we don't need it for our project needs. But it's a pretty important component in large data warehouses. In small data warehouses, it's not an issue. But Islam, please turn off. Good, better. And finally. We have a type of load processing which is about real-time or near real-time data. So you know, most of data warehouse data is something like historical data collected over some period of time. But important data for your everyday operation, for your everyday business activities is data collected from operations and processed and used for something like a tactical decision making. And here in near real-time and real-time data, we have three main types: trickle feeds, messaging, or streaming data. And all of these data feeds differ by where data is accumulated while waiting to be processed by analytical applications. So the data origin is important here to distinguish trickle feeds from messaging from streaming. Okay, and some words about big data, because on this diagram we have a pretty interesting element, big data, something like what is it about? Okay, data lake, you see, it's something new these days for big data loads, for big data situation. Data warehouse is transforming into a structure which is a combination of classical data warehouse and special data transformation mechanism. Remember, I mentioned that ETL now we can transform into ELT. So with data lakes, we do it exactly like this. So we ingest data from different data sources, ingest data, so extract and load it directly to data lake. And after this, data in data lake can be integrated, transformed, explored, and used to evaluate different kind of evaluation with different BI solutions or data analytics solutions. So this is something like a new modifications to a classical data lifecycle, classical data pipeline. Okay, so now after all of this fundamental stuff, we can go to more details to the activities. So activities related to data warehousing, to development of the data warehouse and BI capabilities in your organization, in your business. So we have 6 activities, 2 planning activities, 2 development activities, 3 development activities, and operational activities. So after planning, developing, and deploying some data warehouse in your information system, you need, of course, to maintain data products in your data warehouse, something like this. Everything starts with understanding requirements, and what is important here, that development of the data warehouse is different from developing an operational system. So a data warehouse is not an application to automate some operational process, some operations. It's different. So operational systems, usually they depend on precise and specific requirements. So we need to have a specification, what we in Russian call ТЗ. So with very detailed description of the functionalities, inputs and outputs, and architecture of the specific system. But with the data warehouse is different. It's also a technology, as I mentioned before. It's also a kind of application, data warehouse management system. But data warehouses, they are designed to bring together data that will be used in a wide range of different ways for reporting, for analysis, for different kind of visualizations. And this data usage can evolve over time. So we can start with a simple dashboarding, and then we can go to some, I don't know, strategic forecasting models, etc. So data usage for the warehouse is not fixed in the beginning. We don't have it in ТЗ. We don't have it in definition project, as we call it in English. And moreover, we need to spend some time on initial phases on development of the data warehouse and ask questions related to capabilities and sources of data to support these capabilities. So a lot of time you need to spend talking to, as we call it, stakeholders, people from different departments in your organizations, what their expectations with respect to analytical capabilities, because analytical capabilities dictate the data warehouse design, especially if you're talking about Kimball's model, because Kimball's model, it's a combination of data marts. We want to have as much as possible information about those data marts needed to different data analysis applications. So in gathering requirements for data warehouse projects, we need to begin with the business goals and strategy. we need to identify the scope of business areas and processes in your organization. This is important. Then we need to define, maintain the architecture, technical architecture. Then technical architecture is just a part of the equation. Also important is that how we can arrange data warehouse management process. So just look at what kind of participants we have here. You don't find here any DBA. Remember, database administrator. So some people may say, okay, I have a database administrator. Let these people be responsible for management of the data warehouse. But it's not as simple as this kind of solution. Make DBA the manager of data warehouse. So you see, we need a data warehouse BI specialist, BI platform, data storage, information management. So usually all this functionality is not functionality and qualification of the DBA. So then important activity development and of the data warehouse and data marts. And 3 concurrent track here. So in parallel, we need to focus on data modeling. So remember, if we use the Kimball's approach, so from the very beginning, it's dimensional data storage, dimensional data warehouse. Then in parallel, technology that we can use for these purposes is important, because data warehouse, it's a technology, it's a technical solution, it's not organizational stuff. And BI tools, what kind of BI tools we can use, and BI tools should be easily integrated with data marts. So you know, data warehouse is combination of star schemas, data marts, and we need to use BI tools that can easily consume those data marts and generate some valuable results from those data marts. So we need to map sources to targets, remediate and transform data. So these are development efforts, number 3. Then after this, the same like with your homework, you develop database, then you need to populate the database with some data, real data or synthetic data. But this is a really important part of the development efforts. Our population approach addresses multiple issues, including latency, sources, batch windows, or upload intervals, etc. So it's not like, okay, I will take something like a data generator and populate my data warehouse with something. No, it's a different. It's a different, and many issues should be taken into account in filling data house with the data that really represent your specific business case, business processes, and especially analytics that you want to build on top of this data warehouse. Because you remember, data warehouse is for specific purposes, for business intelligence, for analysis, for decision support. Okay, and then implement the business intelligence portfolio, group users according to needs. As I said before, again, contact all departments just to understand what kind of analytics those departments need. So marketing department needs analytics for possible customers to your products. I don't know, product analytics need something else, sales analytics, they need information about different products and statistics about sales, etc. So you need to understand and you need to build BI portfolio. So it's a collection of data marts that you need to have in your data warehouse. And then maintenance process. This is everyday process that we need to have a special management people for data warehouse, the people who are responsible for release management, monitoring your load processes, monitoring BI activity and performance, and some other stuff. So as I said, this is everyday activity. If development requirements, it's something like one time, you do it once and then implement. Maintenance is an ongoing activity. Release management. And now some words about tools. What kind of tools we can use for data warehousing? Classical tools are metadata repository. And it's pretty interesting that metadata we can use for data warehouse design. Because metadata repository, these tools usually they have ability to stitch metadata, description of the data with a variety of sources. And data warehouse is an integration of data from different sources. So metadata can be really helpful in this integration because metadata collects data about all data sources and data model lineage. Data lineage means we know about origins of data and we know how data travel through the processes, departments in your organization. And this information is really important for data warehousing. Then data integration tools. So these tools can be used to populate data warehouse with real data from real sources, applications, and external sources if needed. And a variety of data integration tools also offer integration with BI. So not just integration, data integration from different applications, but also integration of the data warehouse and data marts with different BI solutions. And these data integration tools can support import-export of workflow messages, emails, and even semantic layers. And as I said, modern solutions like data lakes and data lake houses, they have this kind of tools embedded, something like internal tools to support this integration. So this is pretty helpful these days. Also, business intelligence tools. There are different kinds of BI solutions these days. Some solutions, they have good visualization capabilities, different diagramming, but other BI tools, they also provide some pretty complex and comprehensive data analytical solutions and data processing solutions. So, and here we may even have some operational reporting capabilities embedded into BI tools, business performance management tools, operational analytic applications using some multidimensional analysis. And here three classical implementation approaches exist, like relational OLAP, multidimensional OLAP, hybrid OLAP, etc. So these days there are some tools that we can use for in support of data warehousing in your particular business case. What else? What kind of techniques can be used to build data warehouse? Prototyping. It's a pretty popular solution. So before you can build some solution that you can use in your business, you can play with some prototype with a smaller functionality, but you can use it to evaluate the state of the source data. And this evaluation can bring you to more accurate upfront estimates for feasibility and scope of efforts needed to implement a good data warehouse. Self-service BI. So this is a channel, delivery channel within the BI portfolio. Visualization and statistical analysis. Usually these are tools embedded into self-service BI that allows for rapid data exploration and delivery. And also audit data. Data auditing can be used like a technique for more detailed troubleshooting in your data warehouse when some data issues arise. Different kind of data issues arise because when we're talking about data warehousing as an integration of data from various sources, different kind of sources, internal, external, structured, unstructured, semi-structured data. So you can imagine that during this integration, during design and implementation of the data warehouse, different data issues may arise. So data auditing is a pretty popular tool in support of this data integration process. Okay, there are some also implementation guidelines, but I'm not going to dive into detail. Usually I leave it for home reading because it's more for real specialists who do data management. So, because you know, Dama DM it's not a classical textbook. It's more like a guidelines to professionals who are really data experts in different organizations. And it helps to better organize your data-related activities in your organization. But we can also use it like a textbook, but not all elements of the chapters are really important for educational purposes. But again, for us at this point, it is important to understand the basic architectural solutions. So you see there are two approaches how to build your data warehouse. So these are two approaches. We can use build-in-months approach. It means that we can start with a relational normalized data warehouse where we can combine all data from different applications in your organization. And then from this normalized database, data warehouse, we can generate any number of data marts depending on what is your particular needs. You can build data mart for the sales department. You can build data marts for the marketing department. You can build data marts for, I don't know, your CIO in your organization who need to make some strategic decisions. So depending on who is an end user of these analytics and what kind of reports or what kind of diagrams you really need for this particular user, okay, you can create a specific data mart, a star schema, generated from the relational database. So idea here is very simple. We have a relational data warehouse and we have dimensional data marts. And the second approach, we can start directly from the dimensional data warehouse as a collection of data marts connected by conformed dimensions. So one of this approach is you can use, for example, for your project activities. We can discuss it a little bit later today. So first of all, we can look at homework file that you need to do. And your homework file is based on Bill Inman's approach. So from your database that you have built for your particular business case, you can use it like a data warehouse. And from this data warehouse, relational database, you can build a star schema, a dimensional model for specific analytical needs. As I said, you can choose, for example, sales department and make star schema for analysis of the sales. It would be just easy and straightforward. If you want to build several data marts, it's also okay. But for the purpose of homework, it is enough if you can build just a single data mart, a single star schema for specific analytical needs. So if we go to the homework, and by the way, as I mentioned in the beginning, there is a lot of publications on data warehousing that we can use for reading. So remember, in the beginning, I used the paper by Shoaib Nemri about data warehouse. Pretty good reading. Just recommend you. There are also papers, again, at medium.com from Luis Oliveira. Some more, there are some interesting watching. If you can get access to those YouTube videos, not all of them are available without VPN these days. But anyway, if you can get access to it, you can better understand, for example, what is the difference between tabular or relational data model and multidimensional models. It's a pretty good and high-level explanation, so you can better understand. Again, here, multidimensional virtual tabular, and this is 1 hour lecture about it from our Pragmatic Works. Now, what else? This is just an illustration. If you go to this YouTube video, so it explains how analytics works in terms of, so we have a data report analysis and how we can build it. So reporting is dashboards. Usually BI application generates such a visualization, but important is the general pipeline look like this. So from data sources, we do integration in data warehouse or data lake, and then we go to data marts for such reports and data marts for different analytics depending on what are data consumers. So we are here. So you have a data warehouse, and now you need to build a data marts for specific analytical purposes. So data integration, about data movement and transformation between sources and target systems. Data warehouse is where data is integrated. This is your database. And data marts, the subject-oriented data assets, subsets of your data warehouse. So some more watching here, we just recommend you. And now, okay, we can maybe look at your homework. So we just finished golden records. So now we are at stage 7. So what we need to do multi-dimensional modeling for BI. So this is idea of the homework 5. And this is essentially about experiments with star schema building tools. So how to build star schema for specific analysis from your relational database. And for your particular business case, for your particular business process, what you need to do, you need to design data warehouse. Essentially not a data warehouse, but data mart, a star schema for specific business analytics purposes. So steps are like this. Business process, identifying the grain of a fact table. Fact table is important here because facts, quantitative parameters of a specific business process that you want to analyze, like sales, for example. Okay, and this will be a center of your star schema. And then you need to choose dimensions or those attributes that describes those facts. Descriptive attributes. Then choose measures to include in a fact table. And when we have fact table and when we have dimensions, we can build a star schema. Okay, it's Wednesday 14, actually Tuesday 13, I will change it. On 14, we have to discuss it. And as some tutorials or tools how to build it, how to do it, we can look at some of these videos. Like, for example, master dimensional modeling lesson. Why use dimensional model for data warehousing? Also, as a recommendation, maybe this lecture from Pragmatic Works, designing your data warehouse from the ground up. Pretty good tutorial, explains in detail, step by step, what you need to do to build a star schema. Some other good tutorials like data warehouse schema design. It's a smaller, something like 33 minutes. So dimensional modeling and star schema. So focus on how to build dimensional model from your relational model and how to build a star schema for your particular data mart. Then another good video is data model tutorial, star schema. Perhaps I'm not recommend you to start with this because it's more about Kimball approach. In your homework, you can do in-months approach. So we have a relational database. We can use it like a foundation for your relational data warehouse. And from this relational data warehouse, we can build a star schema. It's easier. But for the project work in May, June, you can play with Kimball approach if you find it comfortable. If you find yourself is pretty comfortable with dimensional modeling, why not? You can start it from the beginning. You can skip relational database and from the source of data from different applications, you can jump into star schema. But anyway, I would recommend you to use in-months approach from relational to multidimensional. What else? Some other nice videos. So short 25 video about creating dimension tables. The focus is on Power BI, especially for those who have some experience with Power BI. Maybe you have Power BI in your computers. Why not? In this case, you can play with the dimension tables that can be integrated into Power BI and visualized immediately. So for your project activity, it's just perfect. But if not, you can just play with the multidimensional modeling, and that's it. From single table to star schema, also pretty nice tutorial, 40 minutes, and it explains how you can build data mart from your relational database. And then, okay, I think that's it for today. About term project, we can discuss it maybe after the break, after your holidays, because I'm not going to load you with some ideas about term project today. We can do it in May. Okay, so that's it for today. I think we can stop it at this point. And okay, stop recording.